Hello friends, this is Durga again from IT Varsity, a one-stop shop to learn all the technologies. At this time we are talking about broadcast variables in Spark using Scala. And as part of this video, we will try to define the problem statement and design the application. So the problem statement is get the total revenue per department for each day. Okay, so here the keywords are total revenue per department, and we should display the department name which makes more sense, and we have to do it for each day. So these three are the keywords: total revenue, department name, and day. Now let us visit the data model. You can click on this URL, try to open it in a new tab by right clicking on it. uh, when you click on that, you will go to the data model of the DB, using which we have to generate the total revenue per day per department. So if you look into this, orders and order items are transaction tables. Order is the parent table. There will be one entry for each order, and order items is the child table. Orders will have many order items, and for each order item there will be one entry into the order items. So the relationship between orders and order items is one to many. And then we have to get the department name, which is here. There is no direct connection between the departments, which is a master table, and the order items or orders, which are transaction tables. So we need to join um, departments with these tables to get to include the department name also, to get the revenue per department. For that we have to join all the four tables. We will come back to that in a moment. Now let us validate how the data volume is in these tables. Okay, so I am going into the to my directory where I have the data. I have data for all the 6 tables here: orders, order items, departments, customers, categories, products. They are in the files. It is in the GitHub code, GitHub repository. If you want to know where it is, you have to go to the same page, transformations and actions overview, and here you can download the dataset from GitHub. When you download it, actually if you go back to this topic, and if you actually click on these videos, you will understand how to download the data and how to set up the dataset for you. So here we have 6 tables. Okay, and let me actually delete all underscore success files. They are not required. Okay, now there is no success file. Okay, and if you look into the data size, order items is 5 MB, orders is 3 MB, rest of the stuff is small. Products is only 174 KB, customers is only 953 KB, categories is only 1 KB. We don't need customers for our problem statement in this case. Okay, and you can actually do cat order items. Let's start with orders. Actually not cat, it is wc-l. To get the number of lines in the dataset, you can use this command. You can see there are 68,883 records. Order items, it has 172,198 records. And then products, 1,345 records. Categories, because from order items you can go to products, from products you can go to categories, and from categories you have to go to the department. So department is the higher level table, then categories, then products. They are the master tables, and then we have the transaction tables. So categories has only 58 and departments have only 6 records. Okay, so we want to get revenue for each of this department. For that we have to join order items with products, with categories, and then departments, so that we can get the department name for each of the product order item. So in this case, instead of using a traditional join, what we will use is, we will try to do the broadcasting. We will try to use the broadcasting feature. Department name is in departments. To get department name, we need to join these tables: order items, products, categories, departments. We will first join products, categories, and departments. Again, you don't need to do conventional join for this thing. You can explore other options also, but for now I am using conventional join only to get the mapping between product ID and department name, just to demonstrate. Is this the perfect design? Need not be. You don't even need to use Spark to to build the hash map joining products, categories, and departments. You can use plain Scala to do that, or Python to do that, or Java to do that. You don't need to use Spark, which is the distributed computing framework. The perfect design will be to join products, categories, and departments out of the Spark using conventional programming languages, because the volume is very small. Even if you have millions of orders and millions of order items, your products, categories, and departments will be few. Departments will be very few. Categories also will be probably 10 to 100, tens to hundreds, and your products will be hundreds to thousands, or uh, tens of thousands. You will not have millions of products as part of your company. So you can offload uh, joining the smaller tables out of the Spark itself and do the join locally, and then get the mapping between product ID and department name. Use that, so the number of records of that mapping will be same as products. Whatever number you have in products, the same will be there. And then you can build the hash map, and then you can actually broadcast that hash map which contain product ID and department name, and then we can actually join orders and order items to get the total revenue, and do a lookup into hash map with product ID to get the department name. And then we will use the Spark API to reduce by key to compute revenue for each date and department. So this is the design which you need to follow. Only deviation as part of the implementation will be from the perfect design will be, we will be using Spark based join itself to join products, categories, and departments. But you can use regular programming language constructs to do that. You don't need to use Spark for that. You can do it locally, locally in the sense without getting into the overhead of Spark. You can actually join these tables and build the hash map and broadcast it. In our case, we will be using Spark based join itself to do so. Okay, so that being said, let's look into the implementation as part of the next video, and I hope you are enjoying the content of the topic. If you like it, or if you have to provide the feedback, or if you have to give the rating, please do so, so that I can sorry, if you think otherwise, if you think there are some issues with my content, please raise the concern, so that I can work on those issues and make sure it is improved over time. That being said, thank you. Bye.